This video is about linear programming, so we are going to determine if a solution is in the feasible region and analyze linear programming problems. So the feasible region represent the points that satisfy both inequalities and therefore are solutions to the system of inequalities. So just like when we did a system of equations, there's going to be two graphs on the line, and now they're also going to have shading that overlap. So to know if a point is a solution, it has to be overlapping in the darkest region, or it has to be on a solid line that borders the feasible region. So when I look at this first graph, this navy blue part at the bottom is going to be my feasible region. So we need to know if the point's in the feasible region or along the solid line at this point right here. So the first point we have is 4, -2. So I'm going to go to 4, -2. This point is in the feasible region. So we would say, yes, it's a solution. When we go to the next point, 0, 2. So 0, 2, 0, and go up 2 to the y-axis. This is on a line which is a solid line, and it's bordering my feasible region. So this is also a solution. The next point we have is -6, 3. So -6 up to 3. This point is in the tan colored region, which is not my feasible region, so this is no. The last point we have is 7, 3. 7, 3 is along a dotted line. Remember, a dotted line does not mean it's a solution, it's a point that does not work. So this is no, it's not a solution. Let's try again looking at this second graph. So determine if the point's a solution or not. So let's go to the point 0, -4. 0, -4 is on a solid line. Remember, this darkest shaded region is my feasible region, where all of the points work. So this is a solution. The next point is 0, -7, which is on a dotted line. So this is not a solution. 2, 3. So if I go to the point 2, 3, it's in that darkest shaded region. So yes, it's a solution. Our last point is -8, 2, which is not in the darkest shaded region, so it's not a solution. So let's apply that to a word problem. So you are a professional dog walker. You also do quite a bit of babysitting. During the week, you have 16 hours or less that you can devote to these jobs because you are very concerned with keeping your grades up. Dog walkers earn $10 an hour and babysitters earn $20 an hour. You are trying to save money for college and your goal is to earn at least $100 a week to put into your savings account. Let X and Y represent X represent the number of hours spent dog walking and Y represent the number of hours babysitting. So we've already given you the equations and the graph below. So this first equation here is representing the hours, and the second equation is representing the money you make. Now, when I look at the graph, the darkest shaded region, so on this screen, would be the navy part. This is your feasible region. So points have to be in the feasible region in order for you to do that job for as many hours as it asks. So in number 9, under these conditions, could you dog walk for 3 hours and babysit for 6 hours? If so, how much money would you make? So we're going to look at the point 3, 6. So 3 hours of dog walking, 6 hours of babysitting. It's in the feasible region, so you could work that. So we are going to substitute into our money equation. So we get $10 an hour for walking the dogs. So 10 times 3 plus $20 an hour for babysitting. So when I multiply this, I get 30 plus 120. So I'd make $150. So under these conditions, could you walk for 3 hours and babysit for 6 hours? Yes, you could. And you would earn $150. In the next one, under the condition, could you dog walk for 2 hours and babysit for 2 hours? So 2 hours and 2 hours puts you in this green section, which is not our feasible region. So under these conditions, we can't do that job for those many hours. So we would just say, no, you can't, and we don't need to figure out how much money we would make. No, you could not. Number 11, what is the maximum money you could make if you only dog walked? So when I look at dog walking only, I am looking along my x-axis. There are 2 points that would allow me to only dog walk. If I did it for 10 hours or if I did it for 16 hours. I want to know the maximum amount of money I could make. So I need to think logically about this. When I make maximum amount of money, that means I'm working more hours to get more money made. So I want to look at the point for 16 hours. So I want to look at 16.0 into my money equation. I don't care about the point 10.10 because that would not give me the maximum amount of money. So $10 times 16 hours plus 20 hours times 0 would get me 160. So how many hours would I have to work and what would my maximum amount of money be? I would say you could walk dogs for 16 hours and make $160. In the last equation, it says, what's the maximum amount you can make if you only babysit? So if we're only babysitting, now we're looking at the y-axis. So on the y-axis, there's 2 points that border my feasible region. Here at 5 hours and here at 16 hours. So again, I'm trying to figure out the maximum amount of money I can make. So there's where some logic comes in again. So would 5 hours or 16 hours get me more money? Well, the more I work, the more money I make. So I care about the point with 16 hours. So I'm going to look at if my point is 0, 16, how much money would I make? So 10 times 0 plus 20 times 16. Remember, we're getting this equation from our money equation right here. So that would be 0 plus 20 times 16, which is 320. So I'd make $320. So you could babysit for 16 hours and make $320. So let's look at another example. So in the next example, you're working for your mom's company over spring break to earn some spending money. You spend your time working on 2 different tasks, answering phones and working in the mailroom. You are able to work no more than 8 hours that week, and the budget of the company allows you to make $90 or less. You earn $10 answering the phone and $15 working in the mailroom. Let X represent the number of hours spent answering phones, and Y represent the number of hours in the mailroom. So remember again, the darkest area is the points that will work in both equations, which they've given to you over here. So the first equation that we have is hours, and the second equation that we have is money. And our feasible region is this dark navy section. So the points have to be in that in order to be able to work under the conditions. So under these conditions, could you work for 1 hour answering phones and 6 hours in the mailroom? So 1 hour answering phones, 6 hours in the mailroom is not in the feasible region. So we're not even going to figure out how much money you could make. We would just say, no, you could not. Number 2, under these conditions, could you work for 3 hours answering phones and 2 hours in the mailroom? If so, how much money could you make? So 3 hours answering phones, 2 hours in the mailroom is in the feasible region. So now we're going to look at our money equation. So $10 times 3 hours answering phones plus $15 times 2 hours in the mailroom. This gets us 30 plus 30, $60. So you could make $60 for 3 hours answering phones and 2 hours in the mailroom. Find the maximum money if you could. So if you decide to only work in the mailroom. So if I only work in the mailroom, that's along my y-axis. So what point is touching the feasible region that would get me my maximum amount? So I want to look at the corner points here. So this corner is 6, 0. So I want to look at if I work 0 hours answering phones and 6 hours in the mailroom, how much money would I make? So remember that our money equation is $10 times the hours answering the phone plus $15 times the working in the mailroom gets us 0 plus 90. So you would make $90. So you would make $90 for 6 hours in the mailroom. What if you decide to only answer the phone? So answering the phone on the x-axis. So I want to figure out what is my highest hours I could do that job to make the maximum amount of money. So the most hours is at this corner again, which is 8 hours. So I'm going to answer the phone for 8 hours and not work in the mailroom at all. So this point would be 8, 0. So 10 times 8 plus 15 times 0 gets us 80 plus 0, which is $80. So you would work answering phones for 8 hours and make $80. The last question, what if you decide to work both in the mailroom and answering phones? So there's a lot of choices that we could do working in the mailroom and answering phones in a combination. The tricky part here is that we want to figure out the maximum amount of money. So we're not going to test every single point that's on our graph. The only point we want to work on is where do the lines intersect the feasible region. So this point right here represents the maximum amount of money we could make if we do both jobs. So in this case, it's 6 hours answering the phone and 2 hours in the mailroom. So we're going to test the point 6.2 to see how much money we could make. So $10 times 6 hours of answering phones and $15 times 2 hours in the mailroom gets us 60 plus 30, which is $90. So you would make $90 by answering phones, because remember, answering phones was our X value, and our Y value is the mailroom. So by answering phones for 6 hours and working in the mailroom for 2 hours.